Hey, Chuck, this is Earl. Are you there?
You should
Hey,
go see.
yeah, we see you and your cat
Oh, where's my cat?
behind you.
Pardon me, I'm coming off a bad flu.
Yeah, you said you had the flu you were just dealing with. Well, we did a little introduction here before we just called you, so I'm ready for you to start if you want to start with the things you wanted to share with us.
Okay, well, I'm going to try seeing if I can share the screen with you, because if I can, I'd like to use my outline I used at the beginning, because it makes a couple points about the history, right? So let's see if this is going to work. Hold on a second.
Hey, we can see that just fine.
Can you see it fine? Okay, hold on a second.
Yeah, terrific.
I decided that, I've done several of these delayed things 20 years after, 30 years after. And I decided if I would take a couple of minutes and go back and really put a base under everything that happened. And I call it the word distributed intelligence because that's the thing we did 1970. We came up with this concept in 1970 that online systems for history. In 1970, half you probably are old enough to remember 1970. I was definitely in the middle of that. I was designing computers, and using computers to design with, and everything else at the time frame. Everybody had these central expensive computers, and they were getting, with the System 360, they were getting to be smarter and bigger. Everybody was solving problems that could be solved in a big concentrated system like that. They had one set of entries that tried using data entry, and it actually worked for a while. But I'm going to tell you a story about why distributed intelligence works and central doesn't. In 1971, GE, who was one of the players in the market at that time, convinced JCPenney to set up a store line in California using an online cash register system that they designed. And the cash register, if you hit a key, it had to go all the way to a central processor, come back and tell it to respond to the key. And that was a traditional online system at that point. It was slow. It was expensive. What's even worse is that I hope probably a lot of you have heard about Black Friday by this time, right? It's the key day for most retailers, right? Well, in Orange County, one of the biggest shopping centers in Orange County, on Black Friday, the entire store lost its cash registers. They couldn't sell anything all day. It was because there was a problem between the computers and the data center. And it luckily buried the concept of doing online systems that way. The other thing that was true is that people were using time sharing a lot, but it was very expensive because, again, you're sending all this data over to do not very much, and then it comes back, and everything else was more expensive. So we decided to change the world. We decided to make an intelligent cash register and do intelligent credit verifying. Sorry about the misspelling. Automated gas pumps. We started our company in 1971 and we failed. We were too early and not enough semiconductor capability. Semiconductors made a difference. Microprocessors, DRAM, and ROM storage. I've got three themes going here, so I'm going to try to mix them in. Without the semiconductor movement, there wasn't intelligent. There wouldn't have been a personal computer market and everything else. It was all driven by the capabilities that the guys came up with who were building chips, right? And all we did was tag along. The 6800 we worked on at Commodore at Motorola. 8080 was done by Intel. Intel spun off to Fajin, who did the Z80, and we spun out to do 6502. As a result of the 8080, the 6800, NCR changed every cash register they had to distributed processing. We enabled this by designing an I/O structure, and I'm going to take credit for this because we don't get credit for it anymore. When everybody designed the microprocessor, Intel, everybody else, when they got all done, they had something that would compute, but they couldn't do anything with the computing. What we did was to define an I/O system that allowed the microprocessor to control anything or do anything just by programming registers in the system. It's called PIA. The patent was at Motorola, and it's been copied by everybody else. All computers today communicate using a derivative of that product. That was the thing that let me sell it. I actually made the sale to NCR. And that let me sell the thing to NCR because they could build a cash register because the cash registers were expensive and they could build it. But the products, both those two products were $250. And people wouldn't consider them for most of the applications I thought they should be using them for. So we set out to design a microprocessor that could sell for less than 10% of the others. We did it in less than 6 months. We enabled the video game market. It was the basis for both Acorn and Commodore. Our other competitor was E80, started by Fujin, who left Intel, and that was used by Radio Shack. And also, but more importantly, by all of the other guys using a language called CPM. Now, CPM illustrates what we're talking about. That thing that matters once you get the hardware working is that you have to have something you can do with it. And you can't just walk in and start twiddling bits, right? So you have to have an operating system of some kind or another. And preferably, you want to have software that's based on the operating system that does something. When we started, I was at GE in 1967 when BASIC was defined at Dartmouth. And I taught the first class in BASIC. I ran a design computer center in Ohio where we were designing jet engines with BASIC because the guys who were designing the engines liked the idea of being able to write their own equations rather than going through a complicated system. And so I had a clear understanding that BASIC was really important. So we concluded that a video-based computer had local storage with a better BASIC would win. I defined the final version of Microsoft BASIC and built it into the PET. We had a good video and a good working tape for $500. I want a small group out there, but let me just make a point because I keep making it. As an aside, Apple, who introduced later, used a hobbyist language. Steve Wozniak did not agree with me that BASIC was necessary. And he didn't have anything to do with creating the personal computer market. We went first and we did it with a product that everybody else had to copy. The Apple II had to be redesigned and they added Microsoft BASIC. Commodore outsold everybody else, even though Radio Shack swapped to Microsoft BASIC. But let's talk about software for a second. Apple II would have failed, except there was a program called VisiCalc. The spreadsheet, which was the first time that anybody had come up with an application that was written for personal computers. Everybody else was doing word processing or something else. The spreadsheet was a new idea. And everybody who had a chance to try it went up about an Apple II and took it to work. Right? Then when the PC came out, Lotus had come out and was a better version of VisiCalc by far. And then Microsoft was determined to own that business, and they came out with Excel, which now is the standard. But we went from a computer that was running BASIC, which you wrote some of your own code, to a computer running a specific application that was written specifically for the microprocessor market. Everybody decided that they couldn't live without spreadsheets. That's great. But that application does not run on big computers. It only runs on distributed intelligence computers. One last point about the reason I put BASIC up is that some guys in Monterey created a language called CPM, and it was oriented towards business applications running on mostly Z80s. Right? And there was a small group, like 20 or 30 companies that were making a good living taking that software and putting it on into systems that they sold at relatively high prices, but they were able to automate those businesses. CPM, you needed some kind of a system when you swapped away from the 6502 as a base or even the Z80 as a base. The 8086 came along. This is the progression from a semiconductor standpoint. I didn't get a chart on it, but let me make the point that the progression is 6800, 8080, 6502, Z80. 8086 became a real standard, okay? Motorola did an equivalent product But the thing that made it the real standard was the fact that a guy by the name of Dwight Davidow, who I used to work with GE actually, came
Chuck,
up with the idea that said,
could you
DRAM
stop the
is,
screen share for us?
yeah, sure.
We
Okay.
got you now. Thank you.
Yeah. I'm now wearing my hat, which I usually wear. The reason for the hat is that my skin doctor says I have to wear a hat all the time. And so I got some nice looking hats so I could wear them.
I like that one.
Okay, we were talking about the transition of the microprocessors. The problem was when they came out with the 88 in the late 70s. I mean, the 86 in the late 70s. DRAM was still very expensive. And so therefore, none of us put a lot of DRAM in the devices. You need some DRAM, obviously. And you don't want to put a lot of them in, and they usually come in 8-bit chunks. So David Allen said, listen, let's make this PC, even though it's got a lot of nice capabilities in terms of the way it does things, but let's have it work with an 8-bit bus. And they created a product called the 8088. I signed up for the 8088 2 weeks after IBM. And everybody decided that that was the product they were going to use. And because of that, and oh, by the way, Intel also committed, or David Al committed to us, and he was the marketing manager at Intel, that we would always have a second source for those products if we chose them, because I was going away from my family, right? And they didn't keep that word. David Al quit. He's running a very successful venture capital country, and Intel went on to dominate the world. The 8088 drove the PC market until the 386 came along. And actually, the product that drove the market then was the 386 SX. Again, a reduced version of it that wasn't so expensive. And those products became the basis for the new operating systems, right? Now, we started with having no operating system. We had to go find an answer. So we went down and signed a contract with CPM. And then we went up to Seattle to sign up for BASIC. And Gates said that he had a deal with IBM that they would use a version that he had done of CPM called MS-DOS, and that we could be the first customer. And so we were. And we ultimately outsold IBM a lot. We won Computer of the Year. We went out. We had a much better product than the PC. But the point is that the only reason that IBM was in Gates's office was they went to his office after the guys at CPM said they couldn't sign a contract. They went there, signed a contract for BASIC with Gates, and then said to him, would you please call Kildall and tell him he needs to sign a deal with us? And Gates 2 weeks earlier had been offered a knockoff of CPM. And so he, making a good business decision, said, I'll provide it for you. Paid the kids that offered him the knockoff $80,000, and the rest is history. Everybody adapted MS-DOS, and that became the market for the PC. On the other hand, that wasn't good enough. The thing that drove Apple was a company called Xerox invented a thing called Windows. Okay. And Steve Jobs, I was out working at Apple at the time, and Steve Jobs went to visit Park. And he came back from Park and said, I'm going to steal that software because they're not going to do anything with it. And so he put it on the Mac. Not the Mac, he actually put it on the Lisa. And then one of the guys working for him put it on the Mac. And it clearly was an important difference in a better product than anything that you could do with MS-DOS. It took us about 2 years to get Gates to agree that he was going to put Windows on. And he was actually getting attacked by IBM, who didn't want him to put Windows on, but a new version of MS-DOS. And ultimately, he made the decision to put Windows on, and the rest is history, right? Windows is a system that allows human beings to use the computer relatively well. I've got a side comment about Microsoft. That was great that they did that. They did Windows. Then in the last 10 to 15 years, they have been attempting to destroy the base they created. They started putting operating systems on that were not compatible or did kind of weird stuff and slowed the machines down. And the ultimate of that was Windows 8. I happened to be in the middle of Microsoft trying to convince them that they should be using something totally different because I was bringing out a new SSD that made the world change. And they said, no, if Obama wants to do the 8, we're going to do it. And so luckily they did Windows 10. Because it's a deviation, let me finish it, and then we'll go back and talk a little bit about some of the software things that happened in the meantime. We drove Apple when Jobs came back. Was Jobs discovered Flash. Now, Flash was developed by SanDisk, and the guy who did it, let me tell you 3 little stories about him. One, he sat and called his team in one day and said, we don't have a company unless you can find a way to make this matchbook into something I can plug into a camera and record devices. But if you do that, I will eliminate film in the next 5 years. His team didn't believe him, but they did it anyhow, and he did. Then, because he liked challenging them, he then took a look at the cell phone and says, this box won't fit. So he defined this little postage stamp size thing called the micro SD. He said, if you can get what you have to do in there, then we'll put that in every cell phone. And they did. And then they did the USB right after that. So I happen to have as my partner in my new company, the guy who was running the test systems for all of that. So he lived through all of that, and he helped bring all of that stuff to market. And he fell in love with my idea for how to buy cheap memory. So semiconductors, the USB we actually did a Computer of the Year award for doing something. It was like a USB. It was a portable drive that did the same thing that a USB does now. And the concept of using flash as your main storage became the SSD, right? And Apple glommed onto it, and they put 2 SSDs in every portable computer. And all of a sudden, they were killing the PC because an SSD is so much faster than a hard drive. Now, I'm going to take half a minute and deviate here. Let me go back to the concept of when I said Jobs fell in love with Flash, he put the Flash into the iPod, right? Because that's all it is. Then he did the cell phone, and then he did the iPad, and then he did the portables with built-in SSDs, all Flash-based, and they just dominated the market, right? He caught on to Flash probably 5 years ahead of everybody else. Now, though, Flash has become a commodity. It's very, very, you can build great big flashes. You can make them very fast and very reliable. And so now we're not talking about DRAM. We have enough of it. It's not cheap at all, but if you put 8K in a PC, that's enough. Some people think they need 16. You don't need 600. But with hard drive, with the SSD, what you get is you get a flash-based disk drive replacement. Now, let me tell you why that's so important. In 1982, we introduced at Comdex the first hard drive PC, 6502, not 6502, but MS-DOS-based PC with 5 megabytes. And everybody in the room, I was popular then, so I had lots of editors there, said, you only got a megabyte and a half. What do you need 5 megabytes for? And I said, that's going to be a funny question later, but let's just tell you, walk downstairs. I have a system set up for you to go try. I sent all these editors down to the floor to work with my team, and every one of them walked back in and said, I will not use a PC with a floppy again. How can I get a hard drive? Well, that's true. And of course, the hard drive totally dominated the PC. If you take somebody and put them in a Windows 10 based computer with a 256 megabyte SSD for under $400, it was under $800, they will use it, get up and buy it, because everybody who's used them once refuses to use a hard drive again. The difference between the performance of the SSD and the hard drive is phenomenal. And the reason is we've moved ahead a generation. We've come up with a way of reducing the cost of flash memory by 75% to us. And then we have built a high-speed version of that runs all of the software, all of the interaction with a human being out of DRAM. So we have an SSD that's dramatically faster than the SSD you can buy today. And it's also much cheaper. And so we're hoping that that's going to be a market dominant product, and we're going to try to get Lenovo and HP to announce it as a next generation PC, because there's 1.6 billion people who own PCs today who would love to upgrade but got totally turned off. The upgrade is not do an upgrade, but now buy yourself a laptop, right? And you've changed your life. Okay, so if you don't mind, we'll jump back and there was a path, right? And you can see that the path was driven by the constant cost of flash, right? It was nothing else. The capabilities of flash has improved so much, and it's so much better to be addressing memory than trying to move out to a track and talk to a disk, that the disk could never compete. If you look at companies like Seagate, they're basically announcing that they're moving away from the the PC market and moving only into servers where the terabytes and terabytes of hard drive make a difference. But if you watch the server market, it's also moving to flash as fast as it can, and which is the reason that Western Digital bought SanDisk. And we suspect that will happen is you're going to see hybrid systems, hybrid being quite a few gigabytes of flash, and then terabytes of hard drives and the cloud stuff. And I'm not touching any part of that market. I'm only going after the PC. I want every PC user to be able to enjoy his PC again. Okay, the reason I say that is that the nice thing about the 5 years to 10 years that the PC was dominant is that all the software got written for the PC. Right? It didn't get written for the Apple, and it didn't get written for anything else. It got written for the PC. And almost every customer out there has some software that he's running and has been running that he can't necessarily match. So he's on a system where he's either got to get a complete PC or nothing, right? And a lot of people swapped over to Apple and bit the bullet. But don't swap over. Put it out of your store, try an SSD, or wait till ours is out of reach and fast. Right? So so that's the kind of the end of the semiconductor. I want to cover one last point about microprocessors. When you went from the 86 to the Z80, I mean to the 386, and then the 486, and then the Pentium, you always got a better machine. So you went down and spent a lot of money upgrading your PC every year, right? Because the processor got better. And then the hard drives get better. And the video moved a lot. It hasn't moved much lately, right? So we were upgrading all the time, and it became the primary market for the PC was people upgrading. And then all of a sudden, they discovered that 4 parallel microprocessors, which is what Intel sells you now, running in that environment doesn't make it fast enough to feel any different than the one you have today, because it can't. The computing performance isn't what's killing it. The DRAM has gotten faster, And so you get some improvement from the DRAM, but luckily all the guys who write software screw that up and make the operating system slower. So what you're doing is you're getting the thing that makes it move. The only thing that makes it move is to fix the system. And we've done that. And that's the next generation. Not to say I'm trying to tell you that, but that's what happened, right? We went from no hard disk to all hard disk, and now we're going to go to no hard disks. And that's okay, because the hard disks serve a very useful function, and we help get their companies up to speed so they can build these multi-terabyte hard drives. The software, though, is the key. The PC has such an enormous installed base of software that you can't get rid of it. You can't even get rid of it. But most everybody doesn't want to get rid of it. They're happy with whatever they've got going. By the way, Excel works, Word works, right? All of the things you use every day work fine. But more importantly, the software that somebody else has written for you or that you've done and used around it works fine, but only if it's on a PC platform. Now, Intel's PC platforms are plenty fast enough. Windows 10 is not perfect, but it's okay. And the SSD sits there and makes the rest of it look great. So what we've done is to create a software, if you will, big mountain of reasons to buy a PC and a reason to use a PC. And then what we've done is to now enable it so you can go back and use that. And Apple will never match it. They're not even trying, right? They can't get an install base that's going to do that. So what's going to happen is that Apple's PC shares will drop a lot. And what's going to happen ultimately is that the PC is coming back. No matter what you've read in the press, no matter what you can't, if you've had a PC and you've been running and everything else, you won't give it up. You just want something better. There was kind of 2 or 3 key pieces of software that drove the market. Obviously, the internet was the key one, right? I mean, it wasn't the key one. VisiCalc was a key one and all that. But the internet capability changed the way people think about using a computer. And then, of course, everybody changed the way again. And they say, if I can't do it on my smartphone, I don't want to do it, right? So the major competitor to the PC today is the smartphone. Well, with all due respect, my first computer had little small keyboards like that, and everybody rejected it. A PC, when you sit down at a PC and use it, it's comfortable. It's got the right keyboard, you feel good with it. You sit down with your smartphone, if you got big fingers like me, you have to kind of work your way around it, but you can still get it done. But the smartphone is not a replacement, it's an auxiliary. So what we've done is we've gone from a history of 1 or 2 suppliers down to IBM, down to no US supplier, although it will count HP as a supplier, even though they're headed here. But all the computers in the world now are built in China. They're all using exactly the same technology. They're all built exactly the same. If you pick up a board and look at it, it's the same. There is no breakthrough in that area. Every so often somebody will try to make the keyboard a little smaller or something else, but actually, as long as it's not very heavy and it's a laptop, you can just use it. So my point is we started with an industry where we had nothing, right? And we built that industry in pieces. The biggest piece was to get the semiconductors right. Then the second piece was to get some software that made it work well, which is what we did first with the BASIC and then the whole MS-DOS Windows thing. And then ultimately, enough of a product in terms of hardware and software that anybody could use it and that you could start shipping it. So we've gone through a series of learning experiences, if you will. But the key is we started with a vision. And I used to tell people when they would come to the first conferences on a PC, is I would tell them, you're going to have at least 2 of them. And everybody would say, I don't even have one yet. And I said, you're going to have at least 2. And oh, by the way, nowadays people have 2 plus a smartphone. And secondly, I told everybody that you can't walk away from using a computer. Okay, So I could go on any further, but I don't think I should. That's my conclusion. Been a fun. I've lived a wonderful life.
Thank you very much, Chuck. We'll have some people coming up for questions now. Who wants to go? Well, I have a couple.
Go ahead.
First, I want to say thank you. Your contribution has wasted so much of my life in terms of times with computers. But I want to thank you for that because it's made such a huge difference. And I was a Commodore user. That was my first kind of computer. Really loved it. I've had great times with Bill Hurd and hanging with everybody. You had a great team there. What I'd like to ask, in all the designs you've done, what would you say is the one you're the most proud of in terms of, things you accomplished? I know you did stuff with the hard drives, and you're doing that now in the 6502, but you designed so many things. Is there a particular one that stands out that you were the most proud of, how you pulled it off?
Yeah, the 6502. Small team of people. We had to move across the country. We had, if you saw how we designed that machine, you would be crazy, because nowadays they won't even start looking at a computer unless they can simulate it and draw it and do all this other kind of stuff. Our drawings consisted of inking in a full-size version and putting it around the wall in the office, and then the designers walk through it. It worked the first time, and it did what I wanted it to do. It dropped the price entry of computers so low that we changed the world. You have a computer in anything you own, whether you like it or not, and that's there because of what we do with 6502.
Yeah, can you tell us a little bit more? You talked a little bit about the flash storage. You told me the other day about the multiprocessor 6502 based thing to do.
Yeah, I talk about that. If you look at the way Intel's brought PCs forward, they make these great big wide multiprocessor applications, right? And you're running one process in one, another process in the other, and that works for them. I designed the 6502 to do a single job well for no money, right? The chip nowadays is so small they hardly can put it on the device, right? So it costs almost nothing to put that logic on there. You put a little bit of ROM and RAM with it, and it thinks, right? And so therefore, I'm doing my new controller, which has got to be very cheap. I'm doing my new controller with 4 microprocessors, each controlling their own flash sector, and then another processor which is managing the I/O. And 5 processors, they have no communication between them. They don't know what the other guy's doing. They don't need to, because each 6502 is a task processor. You don't need a big stack because it's a task processor. So I use 6502s scattered through my designs, right? I started out using 8 in this one, right? Which is when I decided to cut it back to 5. But and because it's so cheap, nobody even knows I did it. But it's faster than anything you can do with an ARM or Intel processor.
When might we be seeing it in the market?
If we ever get off our butts this year, right? We're in the process of releasing the chip in the next couple of weeks, and we'll go to market quickly. And you won't see it. You'll never know about it. It's going to be sold to Lenovo and HP and let them build the new PCs with them.
I'm looking forward to your new product. It sounds pretty cool.
Yeah, well, more importantly, if we're right about restarting the PC business, we can get all the people in the room that already have an old PC and have them go down and buy a new one.
I have a question about the early yields of the 6502. I know at the very beginning you had issues with the yield quality of them. I was wondering, what kind of innovations did you make to increase the yield quantity?
Who told you we had yield problems?
I've read books and seen it in the trade press. I'm somewhat younger here.
Obviously, no, I don't. No, let me tell you something. I mean, I don't give credit enough when I'm doing these talks. The guy who invented that process was a guy by the name of John Pavenet. And his previous major success, and again, you're too young to even know about this, but there was a time in this country when you only processed checks with magnetic ink. And he was the guy that invented the magnetic ink processor for Bank of America. And he then went on to be a computer guy, and then he went on and taught himself semiconductor. He was as good as Moore. And his process, which was single 5-volt in channel, worked. And I don't honestly think we had any yield. I don't remember any yield problems. I mean, by the way, we were selling at a price we could handle the yield problem. I mean, it sounded, when we sold it to everybody, we said we're going to sell it to you for $10. But the product was designed and ultimately sold for 50 cents. Right? I mean, it was it's such a small product, and it's so well designed, and it's just cheap to build. The new ones, I'm going to put those 5 in, and you won't even be able to smell their cost. Right?
Mr. Peddle.
Yes.
This is Don French.
Hi, nice to see you.
I haven't talked to you in a long time. I'll get with you afterwards, though, and I'd like to catch up with you.
Yeah. Okay.
I want to thank you personally for being on for you, because I want to catch up with you. It's been a long time since we've talked, 1977.
Is that right?
Yeah, that's the last time we talked.
1977.
Yep, 76 more likely, because we talked about the MOS Tech 6502 in the Radio Shack office.
Right. Yeah, you were there.
Yeah, you and I talked.
77 was when we really started the PC, right?
Right. Yeah, I met with you because we were looking in 76 of what to do.
Yeah.
And looking at your chips.
76, I moved from Pennsylvania to Silicon Valley. I mean, in Palo Alto, and we did the PET there. Anybody else? Thanks for taking the time, guys. I hope I didn't totally bore you.
No, Chuck, we really, really appreciate you spending some time with us, and we hope you feel better soon.
I'm cured, just not in time to make a good presentation.
And we're going to look forward, and we'll be looking inside our computers for your new product. So thank you very much.
All right, bye-bye.